Hi everyone, this is Maths for Uni. This is question 1H from MAT 2019. The question says, the triangle ABC is right-angled at B and the side lengths are positive numbers in geometric progression. It follows that tan of the angle BAC is either A, B, C, D or E, which have a variety of different square root combinations, like square root 1 plus root 5 over 2, or square root 1 minus root 5 over 2 for answer A, and so on for B, C, D, and E. But each answer, notice, has two different possibilities for that tan of the angle. So let's start by drawing down our triangle ABC. It's a right-angled triangle, and so we can write that it looks something like this, where the right angle occurs at B. And then let's say we put down our A and our C to be there. But as we'll see in a moment, we could swap A and C, and this will give rise to our two possibilities for the tan. So if the side lengths are in geometric progression, then we could say, because the hypotenuse is the longest side of the triangle, that the three side lengths are 1, r, and r squared in appropriate units, i.e., whatever the shortest side length is, let's define new units to make that 1. Alternatively, you could ignore that and make it AR, and AR squared if you're more comfortable. But either way, by scaling the triangle or by redefining our units, we can take 1, r, and r squared to be our side lengths. And these are in, as required, geometric progression. If we assume that r is strictly greater than 1, so that 1 r squared is an increasing sequence, then no matter what, r squared will be the length AC, i.e. the hypotenuse, but the other two sides could be, say, 1 here and r here, or it could be the other way around, i.e. we could have r here and 1 here. This will give us our two possible solutions in each of the cases. Now that we've written down our side lengths, it's worth writing down some kind of equations that relate the side lengths by using trigonometry as well as Pythagoras' theorem. By Pythagoras' theorem, we have that 1 plus r squared is equal to r to the 4. Notice that it doesn't matter which way around we have the r and the 1 for this. Either way, it's 1 squared plus r squared equals r squared squared, which is 1 plus r squared equals r to the 4. This gives us a quadratic equation, or rather a hidden quadratic equation for the value of r. If we solve this equation for r squared, then we will get the following. By rearranging, we have r to the 4 minus r squared minus 1 equals 0. Then we can use the quadratic equation for r squared. So r squared is equal to 1 plus or minus the square root of minus 1 squared minus 4 times 1 times minus 1, all divided by 2, which gives us 1 plus or minus root 5 over 2. Necessarily, r squared must be a positive number, because we couldn't have r squared being strictly negative, and we cannot have r squared being 0, since in particular, r and r squared are side lengths of this triangle. This means that we have to take the positive root in the above, and so we have to have r squared being equal to 1 plus root 5 over 2, because 1 minus root 5 all divided by 2 is negative. Then we can go once more and get the value of r, but again r is a side length, and so we have to have r being strictly greater than 0, giving us that r is equal to the positive root of 1 plus root 5 all divided by 2. We couldn't take the negative root here either. Then, to finish, we're interested in the tan of the angle BAC. On our diagram that we have here, the angle BAC occurs here, and I will call it theta. Again, as we noted earlier, we either have 1 and r like this, or r and 1 like this, and this will affect the tan of this angle theta. In general, tan of the angle theta is equal to the opposite divided by the adjacent in the triangle. If we have the opposite being r and the adjacent being 1, then we have r divided by 1, which is r. But alternatively, we could have this the other way around, i.e. the opposite being 1 and the adjacent being r. And so the other solution for tan of theta is 1 over r. Since we have r equals the square root of 1 plus root 5 over 2, then 1 over r is the square root of 2 divided by 1 plus root 5. But in order to get an answer that we have on the answers given, A, B, C, D, and E, we should write this in a more appropriate form by having our denominator being rationalized, i.e. having our square root inside here being on top. If we do this by looking at 2 over 1 plus root 5, multiplying both sides by 1 minus root 5, then what do we get? We will have 2 lots of 1 minus root 5 on the top, and then the denominator will be 1 squared minus 5, and so that gives us minus 4. And therefore, by cancelling appropriately with the minus as well, we get root 5 minus 1 over 2. Therefore, it follows that the two solutions for tan of the angle BAC are r and 1 over r, which are the square root of 1 plus root 5 over 2, or the square root of what we have here, which is root 5 minus 1 over 2. By looking at the answers that we have for our choices, we see that the answer C is the correct answer. If you've enjoyed this content, then please consider liking and subscribing, as well as checking out our full Udemy course, of which the link is in the description. Thanks for watching, and goodbye for now.